So you hear about some new AI, it's the next big thing, right? But how do we actually know if it's any good? That's what we're digging into today. We're going to cut through all the hype and figure out how to really measure performance. And let me tell you, the answer isn't what you'd expect.
Okay, so here's what we're going to cover. First, we'll talk about moving beyond that simple "does it work?" question. Then we'll get into the hard numbers, but also the all-important human factor. After that, we'll see how this all plays out in the real world, and finally, we'll wrap it up by building a sort of evaluator's toolkit you can use yourself. All right, let's kick things off. We have to start by moving past that simple question, does it work? It's such an easy trap to fall into, right? A simple yes or no. But the truth is, the really important stuff, the answers that actually matter, they're almost always in that gray area in between.
I mean, think about it like this. How do you grade a student? Is it just about their test scores? Of course not. You look at their creative work, how they participate in class, the whole picture. Well, it's the exact same idea when we're looking at new tech.
And that brings us to a really crucial point. A single number, a single score, it's just never going to tell you the whole story. Real performance is way more complex. It's like a big puzzle, and you've got to see how all the pieces fit together, not just focus on one.
Okay, so let's dive into the numbers, the quantitative stuff. This is where we can really see in black and white what this new tech is capable of. The hard data is the foundation for everything else.
And wow, these numbers can be absolutely mind-blowing. Take this, for example. In a factory, they use what's called a digital twin, basically a super detailed virtual copy of their whole process. And by optimizing that, they boosted their actual output by 424%. I mean, that's just a massive, undeniable win.
Or how about this? An AI system that spots faults in equipment, it hit 99.8% accuracy. Now, that might just sound like a high number, but think about what that means. When you're trying to stop a $1 million machine from breaking down, that 0.2% is the difference between everything running smoothly and a total catastrophe,
right? And it's not always these huge, flashy numbers. A 28% improvement in production throughput? Okay, it doesn't sound as wild as 424%, but for any company, that is a huge deal. That's a real, tangible improvement that makes a massive difference.
Okay, now this is where things get really interesting. We can use numbers to see how technology evolves over time. Just look at this table comparing GPT 3.5 to GPT 4 on professional exams. It's not just a tiny step up. In biostatistics, it goes from 80% to a perfect 100%. That's like going from a good student to the top of the class. It's a massive leap forward, and you can see it right there in the data.
But wait a minute. If we stop here with just the numbers, we're missing a huge piece of the puzzle. Maybe the most important piece. We have to talk about the human side of things. And yeah, this is where it gets a little messy, a little subjective, but honestly, this is where it gets really fascinating.
And this slide just lays it out perfectly. You've got your quantitative data on one side, the stuff you can count, speed, error rates, you get it. But on the other side, you've got qualitative data. This is the stuff you have to describe. Things like, does this AI-generated text actually make sense? Or do people feel comfortable using this tool? You can't put a simple number on that. So the big question is, how do you even measure something like that? How do you measure coherence or user trust? Well, there's no simple formula. It means you've got to bring in experts for their opinion, you've got to talk to actual users, you have to actively look for things like bias and ethical problems, stuff that the raw data would completely miss.
Yeah, and this quote just hits the nail on the head. It says, the tech is in its infancy and needs expert vetting. That's so important, because no matter how smart these systems get, especially in high-stakes fields, you can't just let them run wild. You need a human expert, a real person to look at the output and say, okay, does this actually make sense in the real world? It's a critical sanity check.
All right, enough with the theory. Let's get practical. We've talked numbers. We've talked about the human element. Now let's see how they come together in the real world, in places where the stakes are incredibly high. First up, let's go back to the factory. When you're evaluating tech here, it's a mix of things. You're looking at the super precise, nitty-gritty details, but you're also zooming out to see the big picture. Is the entire operation more efficient? I mean, we're talking about measuring things like the smoothness of a surface down to the micro level. We're tracking energy consumption. We're checking for tiny bits of damage under the surface.
And of course, we're looking at things like data speed and accuracy, making sure everything is working together seamlessly.
Okay, now let's switch gears and go to a hospital. Here, the stakes are literally life and death. So performance isn't just about being right. It's about being reliable and, above all else, being safe.
So what does that look like? Well, you're testing AI on tough medical questions. You're seeing how reliable it is in really sensitive situations, like assessing suicide risk, and you're making absolutely sure it doesn't give out hazardous advice. Because in medicine, being mostly right is not good enough. You have to avoid being catastrophically wrong.
And for our last stop, the classroom. This is a totally different ballgame. In education, good tech isn't about raw speed or industrial output. The question is much deeper. Does this technology actually help people learn better and think more critically? Yeah, performance here is measured by completely different things. Does the content line up with the learning goals? Does it have real intellectual depth? And most importantly, does it encourage students to actually engage with the material, to think for themselves instead of just, copying and pasting? It's about fostering critical thinking, not just spitting out answers. So, we've seen 3 totally different environments: the factory, the hospital, the classroom. And in each one, the definition of good performance was completely different. So, the big takeaway? How do we build a framework out of all this? Well, here it is. There's no one-size-fits-all test. What you need is a toolkit, a framework. And it's pretty straightforward. Step 1, define your goal. What does success even mean in this situation? Step 2, pick your tools, the right blend of hard numbers and human feedback. Step 3, put it all together. And finally, step 4, and this is the big one, always consider the context. Performance is never universal. Which leaves us with this. The question we should be asking isn't just, is it good? That's too simple. The real powerful question is, good for what and good for whom? And once you start asking that, you're not just evaluating tech anymore. You're starting to understand where the future is really headed.